to continue the talk, I would like to invite Dagfinn Bergsager, who's present here. So Dagfinn is the Assistant Director for the Division for Research and Dissemination Education IT Department, which is the host department for the Nike project in UIO, and also the BioInt coordination is handled by, and also this department is part of the research proposal that was written. So he is the site manager for the HPC as well. So he has the access codes to the supercomputers. So very responsible position, and also the NRIS and Norwegian Research Infrastructure Services. And Dagfinn also responsible for the TSD, the Tjänster for Sensitive Data, the secure data, the sensitive data pipeline. Later on in our presentation, there will be some companies who will talk about sensitive data as well. So for the Oslo and also for the Norwegian sensitive data, he's the sort of the head of that service, and he's also the sort of the initial people who try to get this AI closer to people with gpt.ui.no. If you have used this, so the GPT hosts it as a service, and to make sure the data is not too much data is sent to US. In that way, he's sort of like a person who initiates and thinks about use case as well. So please take the stage and explain a little bit what you are up to.
This is an ion-based quantum computer. This does not look like a watch with dingle-dangle hanging around. It's ion-based. Maybe the new generation of supercomputers. This usage of quantum computing is so complex or ununderstandable that we will not talk anything more about that. We will try to understand something about supercomputers, and then we do not start with quantum computing because that is too complicated to understand how we will use quantum computing in the future. Is it like I'm there? Okay, let's go into the mines in Lefdal. This is a picture from NRK.no about the new big supercomputer called Olivia. This is the biggest supercomputer owned by the Norwegian government, and it's being installed right now. And what is very special about this supercomputer is that it's divided into two parts. One with HPC and one with AI, which is so it's like two supercomputers put together. Trykker du bare på noen sikter eller noe sånt, eller?
Det skal.
Litt trege.
Ja.
Ja.
3 ganger.
3 ganger, ja, okay. Yeah. So I just brought some pictures of my new friend Olivia. So Olivia is the new big Norwegian supercomputer, and it's taking over as the biggest one in Norway over Betsy. That was the biggest one before. And what is new now is that we have a computer that is very physical small. This is the size of Olivia, and Betsy is much bigger. Olivia is placed in the Lefdal mines under the ground, thousands of meters into the mountain. Betsy is still placed in Trondheim, but it might be moved over to Lefdal after a while. So then we have something about supercomputers, and then I will try to explain to you for those people who don't know what a supercomputer is. I'm pretty new into this because I took over as manager for this department just little bit more than a year ago, and started with the supercomputers. So, what is a supercomputer? I talked to a colleague of mine yesterday, and he said, well, they don't make one big computer. But then they found out this doesn't work anymore. We need a lot more power. We need more RAM, we need more CPU, and we need more storage that is possible to put into one main board of a computer, of one server. So then they started more like a concept. So what is a supercomputer? All right, we have computers, nodes, servers, classic servers with a main board and RAM and CPU, and now GPUs as well. So we need to connect them together with a network, a very fast network. We can't use a regular network, so we need a fast one. What is now very often used by us is InfiniBand. So we set up an InfiniBand switch, which is a very fast network switch. This is actually the first one created in Norway. We bought it, and it's placed actually outside the IT department because Teknisk Museum didn't want it. We don't understand why they didn't want this fantastic museum thing to their... But still, this was very expensive and very big. And it was actually designed and created by someone in Norway. Today you can use InfiniBand, or you can use Ethernet, like this Olivia computer is using a slingshot from Ethernet, but it's a very fast network between these nodes. So then we are able to connect them via fast internet, and then we need, and I got this book from Ole yesterday, MPI, Message Passing in Phase Standard. This MPI is a way that these nodes can communicate. So all the nodes, that can be thousands of nodes, they have to know what every node is doing. And then you have a way to send in the jobs, and then you need a queuing system, and the most common one that we use is Slurm. Then you have something about supercomputers, so how we define a supercomputer. Because there are many researchers now that have what we call iron. They just have a lot of hardware, but they don't have a supercomputer because it's not set up like a supercomputer. So that I will go through the supercomputers available in Norway because there is a limit of how many supercomputers we do have. And it is organized in a special way in Norway because the government owns them and they manage it. And then we are over to the organization here. We have a company called Sigma 2 that is owned by Kode, that owns the universities as well, but they also have their own company to do management around supercomputers in Norway. Sigma 2 has designed, they have to do the administration they get, and they are funded by Norsk Forskningsråd, NFR, just like Nike here. And if you take a look at people working in Nike, you will see a lot of them on this picture as well, because this is, of course, working very closely together. And this is NRIS, Norwegian Research Infrastructure Services. This is the competence. These are the people who know how this computer works. They are doing training, and they are doing maintenance of the supercomputers in Norway. And those are placed at university. The University of Oslo, the University of Tromsø, Arktisk Universitet, NTNU, and Universitetet in Bergen. And this was a picture taken last year, and you can actually see this. You can see. Look at this cool guy over here. Yeah. I'm trying to hide. Back there, up there. And this is the design in Norway. So the universities are doing the maintenance and the competence, and they are sitting close to the researchers at universities, and they are controlling these supercomputers. We have different teams. We have a training team. We have maintenance team. We have different types of teams that is working together to make this computer work. and of course in collaboration with Sigma 2, who is getting the funding and is organizing, for example, this Olivia. So when we were testing out in America, Olivia was produced in America, and we wanted to check that it was okay. We and one acceptance test, then Sigma 2 went over, and of course there were people from us joining them to do the technical testing. So we have this NRIS. These people are NRIS, and Nike is also a part of that. So if then we can see that the Norwegian Research Infrastructure Services is a collaboration between Sigma 2 and the universities. So I hope this was very hard for me to understand in the beginning. That's why I'm telling you this. I've just learned it. This is how it's organized. So then the next thing, I will go through we have some supercomputers, but if you want to use them, who can use the Norwegian supercomputers? Researchers in Norway from academia, industry, and public administration can apply for allocation from the supercomputers. And that means probably everyone in this room is actually able to apply to use these supercomputers. The usage is financed from the institutions that use it. So I think University of Oslo, they pay a part of this. But for the researchers, it's usually for free, because it is, there is a financing model here. But the institution has to pay something. And if you apply under 1 million CPU hours, it will not be, you will automatically get the allocated resources. If it's more than 1 million CPU hours, then there is something called RFK, Ressursfordelingskomiteen. And that is people who are looking into your application, seeing is this academic relevant? Is it something we should use this amount of CPU hours on? And how is it defined technically? So then RFK is 2 times a year looking into this big project, because there are some very big projects in Norway. And if you look into who is using supercomputers in Norway, of course we have Meteorologisk Institute, met.no, they are using a lot of supercomputers, but they don't use our computers anymore. They have their own computers in Sweden. But then we go to the academia, that is the other big users in Norway, and we look at how are they using it. We can see at the institutions, University of Oslo is the big one, but SINTEF is pretty big as well, and the other big users here. Of course, we need storage. I did not talk, but that is also a part of what Sigma 2 and NRIS offer. That is we have a lot of data. And you can see it's a little bit the same. And then if you go to geoscience, this is, we have one user in Norway, which is Mats Karlsson, who has satellites going around the sun to predict sunstorms. It's a very fascinating project with enormously amount of data and unlimited possibility of usage of resources in our supercomputers. So that is why this is so big. So there are like maybe 5 researchers in Norway that use 90% of all the capacity. But they are top-notch researchers, and but now we are getting somewhere else where we have actually hundreds of projects applying to use resources. So to be able to let more people use HPC supercomputers today, NTNU and University of Oslo have created their own private supercomputer that is not owned by Sigma 2, where they have more flexibility. Idun at NTNU, it's a pretty big one, much bigger than Fox, but we are trying to grow up a supercomputer as well. And this is a supercomputer that is growing. This looks like a commercial product, but it's not. It's just a very good designer at the University of Oslo, actually. It's definitely not a product, it's a concept. And just a few years ago, it's typically MatNat and Medfac. They have researchers that have suddenly a lot of money and they want to have use it on a very powerful server. And now we say no. No one gets private servers anymore. You have to put it into Fox, but then you will be allocated the amount of resources that you pay for. And that is a way we are growing our own supercomputers at the university, and we can use it together. So this is growing bigger, and it's more or less for free for University of Oslo users, but some have more access to it than others. And this is how we train the researcher. Okay, we set up a job like this. So, for example, we're working now with HF at the University of Oslo. They have found some pictures of some old writings that they are now able to convert into Norwegian. They were not able to do that with a machine before, but AI technology made that possible. And then they were trying to test it out, and they found out, okay, we can take this picture, we can make it into Norwegian, but it takes 24 hours for one picture on my very powerful PC. And then they came over to Fox and trying to test, okay, now it's looking a little bit better. If we make a job like this, we can do this and this amount of pictures and see what's written in them. But we have 20,000 pictures. How can we do that? Okay, then you have to find create your script on Fox and test it out. And when you're ready, you have to move it to one of the national larger computers. And for HF, they will definitely use this supercomputer called Saga. This is Apollo. It's HP, but this is like the most flexible machine with the definitive most users. So many users, and designed to have all these strange jobs. Probably not 100% usage all the time, to say it that way, but that these big machines, these are like these sun researchers with a large job. They run it usually on Betsy, for example. And then we have this big wolf in Finland called Lumi that also Sigma 2 has bought a part of and find as a part of. This is definitely a very big computer. So I've just listed up these supercomputers that is available in Norway, and there is one more coming up as an official supercomputer that is called Colossus and is placed inside TSD. That is also that we are ordering this now, and this is a machine designed for sensitive health data. So when people are training models on health data, probably from University of Bergen's SAFE, which is kind of the same as TSD, and Hunt Cloud in NTNU, they can send jobs to Colossus, and it is designed for sensitive health data. So then we have a new supercomputer available in Norway for sensitive data. But of course, I think this Lumi machine, this is like the big wolf in Finland. It was rated as number 3 in the world, and it's growing and growing. But it is not like we have Saga, that is easy to use if you go to the training courses from Endres, or Sigma 2, which is also for free, because Sigma 2 offer a lot of coursing and training, which is like much the same people as we have been doing. We will continue to do that, and people go to courses, they test it out on local supercomputers, and then they can run it on Saga with a lot of data. But going to Lumi, you need smart people. This is another architecture. I will not go into that. So, personally, I love using supercomputers. I have done a lot of presentations with Whisper. We are transcribing data from sound on an AI model. This is definitely on Fox. I just want to show the graphs that we have on on this OpenAI Whisper from the National Library that we are running. Definitely, I think that we can run because we have supercomputer like Fox available, and we are using it for daily for many thousand hours of transcribing in Norway. So that was my presentation. Is there any questions? Do we take questions, Sabri?
Take one or two.
One or two questions. Maybe you should have the microphone, yeah.
I'm a little bit confused because I saw the supercomputer with a CPU.
Yeah?
To run artificial intelligence is go faster with GPU.
Yeah. So we call it CPU hours, but we have like a method of calculating GPU to CPU. But like I said in the beginning, Olivia, the new supercomputer that is being set in production now before summer, more than 50% is only GPUs in that one.
Okay.
The old people, when we bought, like for example, Saga, that is running many one-core jobs because it is many researchers who are not able to program jobs to go in parallel on GPUs. That is more complex. Of course, today we have software that we can run on GPUs, but that is a new thing as well. But it's definitely going in that direction, more and more GPUs. Yeah.
So Dagfinn, not all supercomputers are GPU.
Yeah.
So the Saga has GPUs, but our new, as you said, Olivia, it has 306 HG200, the latest GPUs.
Yeah.
So supercomputing, it's not just GPUs. For the AI part, there are GPUs.
Thank you for a very nice presentation. There's a lot of exciting things going on. I've just a couple of questions. The first one is actually to the ethical guidelines, because we got some kickback from the application for health data from the registries regarding AI, saying that it's quite a limited amount of data we could get back because the identification of patients get more easy when you can use AI. So I don't know if you have any dialogue with the registries to ensure that we can actually use health registry data also in the future. And the second one is that I was a little bit surprised there was so little health in the use of supercomputers. So do you have any concrete strategy to how to increase kind of use of this for more sensitive data, for health data specifically?
The strategy for us, now I did not talk much about it, but there is definitely a strategy. There is a consortium that is setting up these days between NTNU, Bergen and Oslo called NORTRE, Norwegian Trusted Research Environment. They are going together now and creating infrastructure for sensitive data. And like I said, we are buying a new supercomputer, Colossus, that will be placed inside TSD with API access designed for health data. And we are in dialogue with the registry data, and that is our strategy now, that we will provide the hospitals, and that definitely might happen. But this is an ongoing dialogue with different registries in Norway and Folkehelseinstituttet. So we hope that this will be a solution for health data on supercomputers that we can train, and we will see what happens now with the AI-miljarden and these 3.4 billion for how. Yeah, there are things going, initiatives going on that we are definitely into it. Yeah.
Yeah, thanks for the presentation. You showed a slide with HPC usage, and I'm not sure if that's just Betsy or just across the board.
That was Sigma 2, every Sigma 2 in 2024.
Okay,
yeah.
And 15% of usage was classed as others. Now, what percentage of that is actually industry? And in a way, it doesn't really matter, but it's sort of, you know, fairly small compared to perhaps some of the other users. And what is can you comment on perhaps sort of what is the strategy for attracting industrial users, and what are the challenges that you're seeing at the moment in doing so?
Sabri, do you know anything about the usage of?
So the exact number is little, not that, not as significant as we wanted. But there is a national competence center. Unfortunately, that Frika couldn't be here for industries to get access. So one aim of presenting this is to show the industries there's opportunity that they could use. So I would imagining after this people might contact you or Enris or Sigma 2 more, and the industries are handled by national competence centers. There is a specific place where industries can approach to get resources. Out of that, we can get the exact number, but it is not that.
It's
big.
low. It's low. It's very low. Yeah. So it's definitely says on the website that it is available. But
Yes.
and we have in TSD we have just 4 or 5 projects that is from industry. Yeah.
Okay. So due to time, thank you, Dagfinn.
Okay.
But you'll be around
Yeah,
here for the
I'll be
coffee
around
break.
Yes.
So one more question about one more addition to what Dagfinn said about the ethics is that Andreas here, he's the main coordinator for the ethics paper. So if you have any contribution, please contact him to get more details. And also for the biological data, there are few users, machine learning users. So after this, the next presentation is going to be from Pubudu.